We can't prevent these things. It's very hard. Unless we can reverse climate change, we're not going to reverse globalization. We can't really readily predict these things. So then we have to get really good at preparing and responding to these things. And that's the challenge.
Hi, everybody. Good evening. I'm going to start in an unconventional way. 4 years and 2 weeks ago, a global pandemic was declared. 48 hours later, national emergency in the US. And we lost in this country 1.2 million Americans. So it's not really in style anymore, but I invite you just to be aware of that for a moment. Thank you. Anyway, here we are now, just over 4 years later, and really the worst is over. We are getting our lives back. Spectacular new medicines and vaccines are helping us every day, and that is cause for celebration. The vaccine that saved so many millions of lives was developed in record time. So there's a lot of great stories. But as we reflect on these historic 4 years, we should also be thinking about the next one. Are our public institutions stronger now, better trusted? Are our healthcare systems better prepared for the influx of patients? Is science less politicized? These questions aren't just rhetorical, but questions that we need to ask ourselves. Scientists have been saying all along that the question is not regarding the next pandemic if, but when. But there is no telling when it will occur or what will cause it or how deadly it might be. So that's kind of pessimistic. But the good news is that in the past 4 years, we've learned a lot and seen a lot of rapid technological advancements to help us prepare for and mitigate the next probably inevitable pandemic. So we're very lucky to be joined tonight by Ashish Jha and Matthew McKnight with firsthand insights on what we've learned and where we're going. So good evening, and it is good. Good evening, everyone. I'm Mary Eintema, the president of WorldBoston, and I'm delighted to welcome you to Great Decisions. Right away, quick thank yous, of course, to the Lowell Institute, which generously supports Great Decisions, our Chat and Chowder series, and our annual State of the State Department program. Thanks also to our wonderful production partner, GBH Forum Network. A recording of tonight's event will be available in the GBH Forum Network archive and on YouTube, and I recommend the archive. Tremendous sources. Thank you to our community partners here at the Boston Public Library for letting us use this beautiful space. And of course, thank you to Natalie Mace and other great WorldBoston staff and board members here tonight. At long last, let's get to our speakers. For the sake of time, please bear with me as I abbreviate, but do go have a look at our website. Matthew McKnight is General Manager for Biosecurity at Ginkgo Bioworks. Biosecurity at Ginkgo is Ginkgo's new $200 million business unit focused on national security, public health, and pandemic response. Prior to building the biosecurity business, Matt spent 4 years as Ginkgo's Chief Commercial Officer and 7 years as an investor at Indus Growth Partners. He also worked previously in supporting business development at Palantir and is an active seed stage venture investor. Earlier, he was an officer with the U.S. Marines and completed a degree in history at Dartmouth and a joint degree at Harvard Business School and the Kennedy School. So I also want to recognize some important VIPs in the audience. Matt's parents and family are here. So big VIP welcome. Ashish Jha is a global leader in driving public health research, policy, and practice. He joined the Brown School of Public Health as dean in September 2020. An accomplished, note the timing on that, an accomplished practicing physician, Dr. Jha is recognized globally as a trusted expert on major issues impacting public health and is a catalyst for new thinking and approaches. President Biden appointed Dr. Jha as White House COVID-19 response coordinator in March 2022, describing him as one of the leading public health experts in America. I'm not going to go through all of this, but he was elected, no, I'm going to skip over that too. Sorry, Dr. Jha. Really an extraordinary bio, and it is just such a treat for all of us to have both Ginkgo and the White House COVID response team in one room with us tonight. So thank you so much for joining us, and I will hand it over to you.
Thanks, Mary. It's great to be here. The world in Boston and Boston in the world, I think, is like something that I've learned a lot more about this organization, but I reflect back, Ashish and I knew each other before we were involved in pandemics and biosecurity, before Dr. Jha was the face of the American pandemic response on all of your televisions. And during COVID, we used to sit in the backyard at my house and light a fire and talk about all these same subjects. So it's fun to be able to do it. Feels like a continuation of that. And then he would be like, "Oh, I have to go do a spot," and run off to some room with some books in the background and tell America how to handle SARS-CoV-2. So I think this is a really interesting moment to continue to be reflective, yes, on the pandemic that we all lived through, but I think for both of us, and we still work very closely together on these topics, we think a lot about what the lessons to be learned are. So it's not just a forgotten set of years of life and treasure. Ashish, you've always said to me, just to dig right in, that we are in an age of pandemics. Like, what does that actually mean? And you have actually explained it to me, and this is actually an honest statement. You've explained it to me a few times, and every time you explain it, I learn something new about it. So would you dig into that first?
Sure. And good evening, everybody, and it really is a pleasure to be here. So it does sound a little scary, age of pandemics. Why do I say that? Look, I would say for the last 10, 15 years, many of us have been very worried that the world was heading towards a major pandemic and that we just weren't ready for it. And I would argue that unfortunately, a lot of those worries came true. But the question is, why were many of us worried? When you think about pandemics, like where do they start? And I don't mean like where was the origin of SARS-CoV-2. What I mean is pandemics happen when you get a virus, sometimes it can be bacteria, other things, but a novel agent that the human species has not seen. It's got to be something new to which the human species doesn't have any immunity. Right? And HIV was a pandemic, obviously SARS-CoV-2. SARS-1 did not end up becoming a pandemic, could have been. And so if you look at the last 30 years and ask, what's happening with novel infections? And when I say novel, I mean brand new infections we've never seen in humanity before. They have been going up quite a bit. And so then if you ask, why is that? Why are novel infections going up? Most new infections in humanity come from animals. They're usually a species jump. So if you ask what's going on in the world, we have massive environmental changes happening, deforestation. Economic growth has meant that we're encroaching into lands and encountering animals we haven't seen before. Climate change is having a profound impact on where animals are, vector-borne diseases. Third is globalization. So I always think about the fact that in 2003, when the SARS-1 outbreak happened, compare that to 2019, when SARS-2 outbreak began, China had about 30 times more domestic travel and about 50 times more global travel in 2019 than it did in 2003. So local outbreaks quickly become global outbreaks. And put all of that together, and you're not surprised that we had a global pandemic. And then maybe the last point I will make on this is often I get asked by policymakers, when I was in Washington and before and even now, they say, well, it was a once in 100-year pandemic, so does that mean we get a reprieve? Like, do we get another 100 years? It doesn't work that way, right? It doesn't reset the clock. And in fact, I think I'd be very surprised if we did not get another global pandemic in the next decade or two. So my view is, look, we can't prevent these things. It's very hard. Unless we can reverse climate change, we're not going to reverse globalization. We can't really readily predict these things. So then we have to get really good at preparing and responding to these things. And that's the challenge. But when I say we're entering an age of pandemics, a whole bunch of things are going on in the world that have made pandemics just dramatically more likely than they were 50 years ago.
Vector-borne mosquitoes?
Yeah, mosquitoes, Lyme disease, et cetera. All right, so can I ask you a question?
Yeah.
Okay, so I've been obviously thinking a lot about the natural sources of new biological agents, right? Viruses. You brought up something to me a few years ago when we were talking about biology and kind of where the state of biology is. People have thought about biological warfare and bioweapons for a long time, but you said this is a technology that is now engineerable. And I didn't totally get that. And like your sort of analogy, you've explained it several times, but what do you mean biology has now become engineerable? A, what do you mean by that? And why does that matter? Like, why should we care that biology has become engineerable, whatever that means?
We talked about this before. So it's really interesting. So for those that, maybe I'll start with 10 seconds on Ginkgo Bioworks, for those that don't know, only because it is the company example of what's happening in bioengineering. So we hear this idea of biological engineering, genetic engineering. You hear about tools like CRISPR, and it's relatively complicated to get your head around it if you don't live in it on a daily basis, until you break it down to its most foundational, kind of like high school biology principles. And you have to start from the base idea that the world, everything around us is grown by cells, right? Plants, human cells, animal cells, bacterial cells. All of those cells are just manufacturing platforms. They make stuff, right? Cancer, cells growing, running amok, right? Making too many more cells. But chemicals, many of our small molecule drugs, proteins, they're all produced by the cell. The cell is the foundational manufacturing platform of the planet, and it runs on digital code in the form of DNA. At the center of every cell, to a first order approximation, is DNA, A, T, C, and G, in many, many long combinations. That's the Jurassic Park, kind of like scene number one. And the thing that is happening in bioengineering or genetic engineering, or all the different names for it, synthetic biology today, is that we are building the tools across scientific centers all over the world to be able to read that DNA incredibly efficiently, that's DNA sequencing, and then not just cut or change, but literally print out de novo sequences of DNA, that's DNA synthesis, print out 10,000 base pairs of DNA and put that into a cell. And just like when you write a computer program and you hit compile debug and then the computer runs the program, we are there and able to put that DNA sequence into a cell, hit run, you feed it, and figure out what your new program made that cell, that manufacturing platform, do. So the acceleration of bioengineering is really about this amazing new way that we will be able to predictively and with highly probable understanding of outcomes program the most powerful manufacturing platform on the planet, cells. And so Ginkgo facility, 300,000 square feet of automated genetic engineering capacity, serving companies from Pfizer to Novo Nordisk to food protein companies, is just out in the seaport by the Harpoon Brewery. And that's what's happening in bioengineering. Why is that important, Ashish? Because if you look at...
I was going to say, it sounds a little scary.
If you look at... Can I come back to the scary part?
Yeah.
I want to do the exciting part first.
Okay. Do the exciting.
So look at human history. Chemistry, physics plus chemistry, electrical engineering, material science, computer chip. The exponential expansion of human economic output since the early 1900s is taking the base science disciplines and making them human controllable engineering disciplines. Chemical engineering turns the barrel of oil into everything around us. Yes, with massive negative outcomes in climate, but everything around us is chemical engineering. Physics gives us modern communication. It gives us the ability to fly across the world and see each other. Computers, we know what has happened in the digital age. Biology is the last one, and by far the most powerful. So that's where we are. We will change the way we produce things on the planet in the next 5, 10, 50 years. The scary part, and I'll pause there and we'll come back to like perhaps what to think about doing about it, is every time we have done that in history with chemistry, physics, computers, human actors have chosen to take that engineerable discipline, the capability to control a base science, and use it in a way that it has been employed in warfare. So instead of just natural threats, we are now entering an era where you will see incredible medicine, incredible economic production, new supply chains, new materials. And we have to just be clear-eyed that bad actors around the planet will take those new technologies and try to find ways to gain advantage in warfare.
So before we go there, because that obviously connects very closely to pandemics and pandemic preparedness, the other part that's a little scary about biological engineering is the fear that while you're tinkering around with cells and DNA, something will go wrong and then something crazy will get created that we can't control. Do you worry about that?
Yeah, like all the time. But here's what's really important.
Not the answer that I was hoping he would give me, by
because
the way.
it is how you have to think about the defenses. But I think you have to be nuanced about how you ask that, like how we ask that question. So one of my biggest fears is that all over the world, nation states seeking to do good things recognize the power of biology, and they recognize it is important to be researching and trying to understand what could happen with dangerous viruses and dangerous bacteria. So people are building these very high security labs all over the planet with very different standards. And so you have this expansion, not just on the natural side, it's climate change, it's all of these other reasons why you will have more threats. Globally, there's more research being done. There's a whole separate category, which is the vast majority, we're in Boston, right? The life sciences industry in Boston works with incredible safety controls, works not with the very dangerous things. They're looking to make medicines and do all sorts of different things. The way to think about it is biology doesn't just make dangerous things, it makes trees, it makes grass, right? So it's a very complicated question. I don't think we can give up the power that's coming from it, but we have to be very clear-eyed about the dangers.
Okay, so now let's connect these two ideas.
Oh, but can I ask you a question on that?
Yeah.
You're in the White House and you're doing SARS-CoV-2 response.
Yeah.
But did you also worry about like the stuff that I'm talking about?
Absolutely.
Okay.
So the White House had officially...
But don't tell us anything you can't tell us.
I'm not.
Okay. But maybe like a little bit.
I'm not.
Okay.
Look, we had a COVID response,
yeah.
And then we had the National Security Council and thinking about biothreats. COVID, I mean, we generally don't want to have like in the White House focus on one disease unless it is a global pandemic killing millions of people. Then it makes sense to have that focus. But very quickly, I realized, and the people in the national security community inside the White House, the leadership recognized, that we were essentially working on the flip sides of the same coin.
That's cool.
And as I was worrying about future variants, how are we going to detect them, right? So I arrived just as the big Omicron wave of January 22 had just subsided. And as far as I knew, we were going to get new variants every day. Things could go very wrong. We didn't know. And I spent a lot of time thinking about how are we going to detect them? How are we going to respond to them? And it turned out my friends down the hall in the National Security Council were thinking about the same set of issues, not for SARS-CoV-2, but for every other potential pathogen in the world. And so there was a lot of overlap in our thinking about the problems in front of us and what we need to do to deal with them.
Interesting. You have optimism about what we can do?
Yeah. So I have by the way, so what Matt and I have done, he's done for kind of, not synthetic biology, but the kind of man-made biology, and I've gotten in the more natural side, is laid out what I think represents a very large set of problems, but also a large set of opportunities. So the question is, how do we begin to deal with the threats? How do we mitigate? How do we lower the risk? I know you've thought a lot about this. So what's your framework for how do we make the world safer from engineered biology? And how do we make the world safer from natural biology that is changing rapidly because of all the changes that we have made through globalization and climate change?
Yeah, so I think the cool thing is it's mostly the same thing. It's mostly the same system you have to set up. And what we try really hard to do when we're thinking about this from first principles is remember that basically this is a technology problem created both by humans inventing bioengineering, but also a natural biotechnology problem. So we have to then take these modern tools of biotechnology we have and say, like, what is the system that needs to be created? And it feels like a big problem until you break it down into like a couple analogies, right? This is not the first time we have had a threat that we've had to build a detection to response system. So today, for nuclear weapons, for example, I don't pretend to know the numbers, but we have massive constellations of satellites and multiple different types of intelligence being collected all around the world, essentially from my reading of books, Boston Public Library. We track most fissile material, and we're able to like quickly identify if somebody's doing something bad and immediately mitigate it. We do the same thing with cyber. We're monitoring the zeros and ones. Every single device at all times is being monitored for threats, and we're able to identify it quickly and then start patching with software. And only do we hear about it anymore. I mean, back in Windows 95, you just like get enough viruses, you had to throw your computer away and get a new one. But now we only hear about it like once every 2 years, and there's like a CNN.com alert, like everybody update your iPhone software. It's because somebody's constantly patching in the background. Well, we have to build the same thing for bio. We've started by doing it, really thinking about where are the choke points where you would identify a bio threat. And so we've launched a program in conjunction with both of the last two administrations where we're monitoring airports. Global travel, as you identified, so every time an airplane lands in, not every time, but many times an airplane lands in going now 9 airports in the US and also in places like Doha, in Qatar, in Rwanda, soon to be Botswana. We're taking wastewater off those airplanes and immediately doing DNA sequencing on it to be able to alert if there is something that is dangerous, either a new variant of, say, SARS-CoV-2, or now we're monitoring for 66 pathogens of concern. That's just like what we do in these other areas. We build a surveillance system. And I know you guys have thought about that a lot, both in the White House and now still in the work that you're doing, both at Brown and elsewhere. I think that's one node, but like, I've always been interested in how you like level that up to what does the global system need to look like?
Yeah, so surveillance, early warning, and basically has 2 sets of benefits to it, in my mind. There may be others. Number 1 is early detection, right? Like you detect a threat early, you can act early, you can deal with it effectively. If you think about SARS-CoV-2, it was probably circulating in many parts of the world, certainly by November, December of 2019. We really didn't get our arms around it until February and March. That's a long time to wait. We missed it for months. So early warning gives you the ability to respond early. Always a good thing, right? Public health, medicine, early warning is good. The second thing it does, and you and I have talked about this, is surveillance is deterrence. So if you are a bad actor and you're thinking about using a biological weapon, and you know the country that you're thinking about attacking has a terrible surveillance system, that is a big target on the back saying, if you attack them, they're not going to figure it out. It'll be months. Lots of people will get sick, and they'll never figure out what exactly happened or who caused it. I have believed that, the debate about SARS-CoV-2, did it begin as a lab leak? Was it natural? That debate, by the way, remains. It's gotten weirdly politicized, but we manage in our country to weirdly politicize all sorts of things. Like Taylor Swift is now politicized. Like, what is happening there? I don't know. Anyway, side point. But the point is, to me, it's not which of those two is it. It is the fact that we don't know for sure sends a very clear signal to lots of bad actors that we are a country that does not have the kind of surveillance system and attribution system that will allow us to quickly figure out who did something and respond to it effectively. So it's actually not just that we're not going to respond effectively, it's inviting more bad actors into the game, and that is what worries me a lot about that. I do think we can build up a surveillance system. You guys are a really critical part of it. When I was at the White House, we put a whole bunch of different programs in. Not enough. We've got to do a lot more. Partnering with companies like Ginkgo was a pretty important part of that, because you can build a surveillance system from the government, but you actually you've got to partner with companies that can actually deliver on the individual products. Anything else to add on surveillance and how you think about the surveillance issue?
Can I be like nerdy for a second?
Yeah.
Okay. So in the audience also is the woman who runs all of our DNA sequencing for biosecurity at Ginkgo. Brigitta's back here somewhere. She's amazing. What you just said is like very, very important to me. In my background, I was in the Marine Corps, and I was an intelligence officer, spent time in Iraq. The thing that we needed most of all, and that we've built massive systems to be able to manage and do so in a way that is appropriate in all the contexts we can talk about, but is literally to be able to say, if you do something, we are going to know about it. And that by itself raises the cost to a bad actor to doing something. The way to think about that in biology is that this planet, like, you remember the movie The Matrix? It had the zeros and ones, right? Like, that's actually, that movie should have been made with A, T, C's, and G's, like DNA floating around. Because it is. That's how the world is literally made. As we start in first principles, it is made of A, T, C's, and G's. And that is a high fidelity information source. Just like in the 1950s when we invented the high altitude camera and started taking pictures of the Earth, and the first application was to build an airplane, the U-2, around the camera and fly it over the Soviet Union so we could confirm whether there was a missile in a place or not. That gave us information that allowed us to say, if you launch a missile, we'll know it, or if you build more missiles, we'll know it. We need to start thinking about the ATCs and Gs of the planet like a new high fidelity information source that can be unlocked. And so when we're building these monitoring nodes, radar stations, if you will, what you're doing is really you're turning the environment, non-human, right? All the pathogens of the world, all of the plants and things that can hurt humans, you're turning the environment into a data problem via the DNA sequencer. And if you can start doing that over and over again, then if something bad happens, you're able to trace it back through the network to understand, was it natural? And if it was natural, fine, we need to figure out how to stop it. Or was it something that a bad actor was trying to create to do harm to our society? And then if we are able to figure that out, there's plenty of ways to raise the cost to actors to do that. But you really need this mindset shift around biology. It is not just happening to us. We are very much able to, in a sophisticated way, engage with it.
You know, what's interesting to me is, as a public health person, this idea of bad actors is a little uncomfortable. Like in public health, we tend to think about...
This was going to be my last question for you.
What's your question?
Like, I've always known you as the public health guy. I've never actually asked the question, have you become a national security guy?
No, I think of myself as a public health guy, but I have come to realize public health is about protecting the health of the public, and that includes threats that come from bad actors. There are bad actors out there who want to use this technology to do harm to the world, not just to America, but to the world. And our ability to deal with that requires a lot of the same skills that our ability to deal with natural threats does. So I have come to realize that these are actually very much aligned agendas, and we've got to bring these communities, the biosecurity community and the public health community, together. Both sides probably feel a little uncomfortable with the other, but we've got to do it if we're going to make the world a safer place at a time we're entering into engineerable biology and all the threats it creates. There is one other part of the response I want to just talk about before we get to questions, which is, so surveillance is really important, right? Both in terms of early response, but also as deterrence. There's another part of this that's really important, which is what I talk about, or the term that we use kind of is the idea of medical countermeasures.
It's a little wonky, but...
It's a little wonky.
Like vaccines and drugs.
Vaccines and drugs is like the English way of saying medical countermeasures. How do we harness technology? Because if technology is creating these problems, I want technology to be part of the solution. How do we harness technology to make vaccines and drugs faster, easier to get?
Yeah, okay. You were just talking about the 100-day thing?
Yeah.
Come back to that in a second. We've spent all of our time on surveillance. The thing we spend all of our money on, Boston, is vaccines and drugs. You've got to get there. Why we spend time thinking about the surveillance pieces because we think that that's, I don't put words in your mouth, but I think it's like further behind.
It is further behind.
So here would be my, I don't think I've ever said this to you, here's like my dream aspiration.
Yeah.
Okay, so if you start with a company like SpaceX is like, I'm going to colonize Mars, right? Like, no one's like, oh, that's too big a dream to colonize Mars. Everybody's like, oh, that's a good goal. It might take you 30 years, and you've got to start with like the rocket that lands itself, and then you're going to do Supply Dragon with the same docking mechanism as Crew Dragon, so you don't have to rebuild the whole thing, and then you're eventually going to get there, and you're like going to have all the things you need. Like, we should set an aspiration. The United States government should set the aspiration to say, we want the ability to identify a biothreat anywhere on the planet, and within not months, not weeks, not days, but within hours, deploy mitigation, vaccines and therapeutics, remotely to that location. That is how cybersecurity works. So I think we should right now we have this idea of the 100-day mission, which is, I think, a really laudable goal, detection to response in 100 days. I think that should be ours. And so that's what technology can do, because every one of those pieces needs to be massively improved to get to that. But like, if that takes us 30 years, that's okay.
We got to get going.
We got to get going.
The part I worry about on this is, so the most amazing thing that came out of the pandemic in a positive way was Operation Warp Speed. And Operation Warp Speed, by every definition in my mind, was a huge success. A little harder to say that when I was in the Biden White House, but I just think it's true, and even people there clearly recognize that was extraordinary. It still took like 7-8 months to get these vaccines tested and studied, and then it took many, many, many months to get the vaccines out to the American people, and it took another 10 to 12 months to get the vaccines out to the rest of the world. Too long. And
too long for some of the threats that we might face in the future.
Correct. Yeah. And Operation Warp Speed got lucky. We got lucky with SARS-CoV-2 because there had been a SARS-CoV-1, right? The original SARS of 2003. We knew a lot about this virus. And when we saw it, we're like, we know where to target. We got to target the spike protein. And we could quickly build a vaccine against the spike protein. We may very well see a threat where we see a virus and we're like, we have no idea what to target here. We don't have that same experience. We've got a ton of work to do to get much, much better at being able to build these things, ideally in days or weeks, and not count on luck, which was such an important part of getting Operation Warp Speed. So Operation Warp Speed, good. We've got to count on less luck and still do it faster. Doable, but a challenge.
Now, let us see about some questions from the audience. Oh my God, many, many, many of them. And a friend will bring you a mic. Okay, so if you really mean it, keep your hands up. All right, we're going to start down here. This gentleman, come on down. Naz, right here, sir. And no, right here in, just go up one row, and to this gentleman right there. Yep, okay. And questions end with a question mark, and there are many of them, so.
Hello, my name's Carson. I'm just curious, like, could you elaborate more on, like, like how like when you were at the Biden White House, you were able to like get down like just like mobilize like the government to be able to respond like to COVID like in a way that the Trump administration wasn't able to do? Thanks.
Yeah, there are two benefits I had. I spent a lot of time talking to Debbie Birx, who was the COVID response coordinator for President Trump. Sorry, not for President Biden. I had a couple of advantages. The number one advantage I had was I had a president who was like all in, right? I could walk into the Oval Office and say, I need this, this, and this. I almost never had to, but if I needed to, I could. And that was an extraordinary power because that means I could call up federal agencies and say the president wants you to do this. And so having the president's backing is everything when you're running the executive branch. That was very helpful. I think there was also, a sense that getting COVID under control, getting the deaths down, the hospitalizations down, was really important for all of the other things the president wanted to do. He had an agenda on climate change. He had an agenda on reducing gun violence. He had an agenda on building up manufacturing in America. And it was also clear that those things would be much harder to do if COVID was out of control, right? So that was the other part. The last part I'll say is, the federal government is very interesting. It is a behemoth. And the federal government is only one part of government. There's state governments and city governments, and the White House doesn't actually have a ton of hard power. It's all soft power, right? So a lot of this is about building coalitions. It's about getting people to compromise. I would have times where the CDC and OSHA would have very different views. OSHA is the Occupational Safety and Health Administration. Very different views on what we should do. A lot of it was bringing them together and saying, there's only going to be one right answer coming out of the administration. We're going to work through it. So in general, it took a lot of work, but I felt like really rewarding work because we could get to a good place, and I had the backing of a president who really cared.
I'm just going to say one thing on that is a learning for us on the receiving end of just governments making decisions and us trying to build technology solutions during COVID. I think each of these has a nuanced lesson to be learned. We would not have had, we as a country, we would not have had large-scale K through 12 test programs that were used to test to keep kids in school if you didn't have state laboratories that were trying to respond on their own. In particular, places like started it, the first kind of big K-12 programs were in Massachusetts, right? And if there was it's always going to be the federal government telling states what to do and how to do it, I think we would have lacked innovation, in particular in biology where it's all very local, right? And so I think that was a learning. I know it's directly correlated with political administration, but certainly when you think about the scale of a 330 million person nation and how to build technology responses.
Yeah, as we get to the next question, go ahead. I will just say the key point here is states are a really, really important part of any national response. And most of the times that's a good thing. Sometimes, especially if you're in the federal government, it can be a little frustrating when states don't listen to what you want them to do, but you take the good with the bad.
Okay, so my friends, we'll go to Mary, and then I can't see who that is in the middle, Martin, okay?
Hi. It's kind of both a national security and a public health question. One of the things that people are always worried about during the Cold War was the weaponization of smallpox. Are we tracking that nowadays if somebody monkeys with the smallpox virus, which I believe is held either here in this country and at a lab called Biopreparedness?
Yes, so there is a whole program around smallpox. We worry about it a lot. Partly because it's just a really nasty virus and has very high fatality, high levels of morbidity if you survive it. There is very careful monitoring of the laboratories where those specimens are held. There's been a debate for literally 30 years of should we even be holding specimens? Should we just destroy it all? I think the argument goes back and forth. Largely, the argument of keeping a little bit has been to be able to use it if you need to in the setting of an outbreak. But we have built a whole vaccine infrastructure. We have vaccines sitting in a strategic national stockpile. So if there is a smallpox outbreak, May that never happen. First of all, if it happens, it'll almost surely be a bioweapon. We've got vaccines built up and ready to go for at least one dose for every American. There's a lot of work on smallpox. That's the good news, thank goodness. The bad news is there are a lot of other viruses out there, and we've got to come up with a strategy that doesn't require us holding a dose for every American for every virus out there. That becomes untenable.
Because also remember, plants, animals, so livestock, not just humans. So it's the viruses and bacteria that cover essentially all of the living things that make up our kind of modern supply chains.
Yeah.
Great. Noel, do you see Martin here? He's in the middle. Raise your hand. Keep your hand up so that Noel can, or anyway, let's get right to him. There you go. Okay. And then while he's grabbing the mic, any students here? Ask a question. Okay, go ahead.
Hi. The engineer in me sees spreading pandemic as an example of exponential growth and decay. And more recently in major media, some public officials have sort of discounted the government response. And I wonder if maybe the public's getting the wrong message, that it's not the response, but it's when it came. And perhaps a response in January would have been very different than a response coming in March.
You can pass the mic back.
Just so I understand, first of all, I'm not 100% sure I understand your question. So, like, obviously, people have a very hard time understanding exponential growth. Like, it just doesn't, I dealt with this all the time where people be like, look, the levels are still low. I'm like, it has doubled. They're like, it's doubled from 2 to 4. I'm like, now it's 8. And what I was trying to say is pretty soon it's going to be completely out of control, and people look at absolute levels because they didn't understand exponential growth. Is your question?
So my question is that a lesson that the public should learn after the pandemic? And if a public official is today saying maybe the response was too onerous or whatever, the public's going to associate they're not going to respond at all to the notion of early response is critically important.
Okay,
Yeah,
thank you.
That's a very good question. I think there is no question it's hard to get people to respond when the numbers are low and your hospitals are not full and most people are doing fine, right? I remember back in February or early March, people were like, oh, more people have the flu right now than they do COVID. I'm like, right now. So that is always a challenge. That's a communication challenge. And there is no question in my mind to the beginning part of your question. If we had responded effectively in January, we would have looked like South Korea, and that was a very different response with far fewer deaths. I mean, if you look at like South Korea, Singapore, a bunch of these countries, they did better economically than we did, had far fewer deaths, eventually ended up having a lot of people get infected, but after vaccines were widely available and widely distributed, and people didn't get super sick and didn't die, and hospitals didn't get overwhelmed.
Okay, so I'm actually going to jump in because I'm holding the mic with a question that we were talking about before. I think probably a lot of people noticed as this unfolded, you alluded to it, the global inequity. And Ashish, you said something very interesting about the problem isn't really solvable by better distribution, but by distributed manufacturing. So how do we make that happen in a capitalist world? Why would the manufacturers do that? So maybe you could play that out a little bit.
So look, here's the way to think about this. Vaccines became available for Americans between January and April of 2021, and some in December, but mostly January to April. And then they became much more widely available for much of the rest of the world 6 to 12 months later. Certainly for the African continent, which was really the last place to get the vaccines. Huge problem. And the solutions, and there are 2 basic sets of solutions in my mind. I think this idea that countries just need to be better, they need to be more altruistic, like good luck with that. Every country in the world exercised vaccine nationalism. India, which was supposed to supply the vaccines to the world, got hit with the Delta wave, and they completely stopped all vaccine exports. So the idea that like we just need to be more moral next time If all of you know how to make humanity more moral, like, please give us some of that, and I'd love to distribute that. But equitably. My assumption is, next time there's a crisis, people are going to do the same thing. So how do we solve the equity problem, given that I don't know how to change the moral composition of 8 billion people? And there are two main solutions. And they're hotly debated, and my view is we should probably do both. One is distributed manufacturing, right? So the reason India could shut down exports is because the vaccine manufacturing was in India, and Prime Minister Modi was like, we're not exporting any. And what are you going to do? All the contracts to the African countries could not be fulfilled. But what if you had distributed manufacturing? What if you had manufacturing plants in South Africa and Kenya and Nigeria and 5 other places on the African continent? That would be really helpful. Your question is, how are we going to make that happen? So the wrong answer, and I'm not suggesting you're saying this, but a lot of people are like, well, let's just build these and wait for the next pandemic. That's not how vaccine plants work. You can't just like build it and wait, right? So you need to create ongoing demand. So how do you do that? Well, there are lots of ways. And I actually think when I look at a program like PEPFAR, this is the President's Emergency Program for AIDS Relief, President Bush's frontier kind of signature global health program has saved 25 million lives. When we invest in public health in these countries, it actually creates a demand for things like vaccines and treatments. Right now, that demand is met by plants in Belgium and New York and India, but they could be met with plants in South Africa and Kenya. So if you can, then those plants are running all the time, supplying vaccines and treatments for regular stuff, and they're ready when there is a pandemic, they can be switched. So that's the distributed manufacturing model, lots of complexity. The other way some people think about it is they say that's too hard. What we want to do is build up massive manufacturing capacity in places that already do it. Look, we had about a 10 to 12 month gap between when Americans could get vaccines and when the rest of the world, or let's say Africa, could get it. What if instead of 10 months, we made that 10 days? What if you could scale up manufacturing to billions of doses within weeks and completely flood the zone so nobody was lacking in vaccines? There's a way to do that too. My view on this is let's do both so that lack of vaccine supply is never the problem whenever we hit the next crisis. I don't know, you've actually had some other ideas on this. I don't know if you want to build on any of this or.
I'll just very quickly give like a very practical example. So I'm heading to Kigali, Rwanda tomorrow night because Kigali, or Rwanda, just opened on December 18th. Essentially the first built-in-a-box mRNA vaccine manufacturing facility with BioNTech, so that they will be able to manufacture mRNA vaccines in Rwanda, certainly for Rwandans, but it's a relatively small country, and then have the aspiration is to have export capacity for the region. Now so it's happening, right? And so that's take a highly sophisticated facility that BioNTech builds, figure out a way to continue to make it smaller, more modular, to bring capacity more and more decentralized for vaccine manufacturing. Now, if you take it one step further, and this is, this aspiration to get to detection to manufacturing a vaccine in minutes or hours, fast forward in the arc of human technology advancement, 30 years, there are DARPA, the US DoD's Advanced Research Projects Agency, programs right now working on moonshots to be able to essentially remote manufacture some of the most critical vaccines in very, very small, very small form factors. So you can imagine if we keep on that technology development curve that this doesn't even become big centralized facilities to a few regional facilities, it becomes hospital-based facilities. It becomes what biology does the best, which is be programmed to make the things that need to be made, and you're doing it in the smallest form factor possible, perhaps even in people's homes. And so that's the arc. The question is, how fast does it take to get to each one of those steps? It's not going to help us if there's a pandemic tomorrow, but it might help us in 10 years if we keep pushing towards it. By the way, mRNA vaccines, DARPA project, right? So 15 years ago, a moonshot project to think you could make a vaccine out of mRNA turns into the answer for SARS-CoV-2, at least in the acute phase.
Okay, we're going to take two lightning questions kind of together. And I'm still waiting for some of my students to ask a question, but it's not happening. All right, so yes, sir, right here. Keep your hand up. No, not Ed. The right behind Ed, the row behind Ed, gentleman right there. Yes.
Sorry, you were so close.
As synthetic biology technology gets better, is it a threat that maybe the technology will allow bad actors to more effectively create bioweapons? And also, combined with that, since this is a global humanitarian, project that can help the entire world, how do we stop potential bad actors from getting that as we roll it out to every country in the world?
All right, and Ed, let's take your question real quick, and then we'll do sort of a lightning
I have a
round.
question about, thank you for the speech. I have a question about preparedness. If something hits, like for instance, private equity has gotten very involved in owning hospitals, so they try not to have empty beds. I'm a business guy, I understand that. So the question is, how prepared are we, because you have to have some slack in there, and things like bandages,
Okay.
everything like that, not just everything.
You want to take the first one? I'll take the second one.
I'll try to take the first one very quickly, though it's not a quick answer. I think, one, certainly, engineered biology in the wrong hands, or the capabilities to engineer biology in the wrong hands, creates a new threat surface for new weapons that can be created. There's absolutely no question about that. You don't have to hear it from me. Back in the fall of 2023, or August of 2023, the U.S. Department of Defense published the Defense Bioposture Review, which they do periodically. This is the kind of largest, most comprehensive version. And they named, you can go read it, I won't name, you don't need to go into it here, they named the 4 countries that they are most worried about on a nation state level, and that is not even to acknowledge that there are bad actors around the world, that are rogue actors, that are individuals who are disgruntled that have access to these technologies that will do so. So it has to be a layered approach. We have done a very good job with the Bioweapons Convention, primarily. 1970s needs to be updated. We can't take the foot off the gas of creating a diplomatic solution. We have to then, as a country and as a group of like-minded nations, demand that biology is defensive only. That we will never participate, even if other countries do, in offensive use of biology. So that's like a political layer. And then the next one that you just have to really be thoughtful about is access controls. The strength of biology and the weakness is that it is physical, it is us, right? It has to be produced in what people think about as the wet lab. It has to be, we are wet, right? All of the digital tools in the world mean nothing for creating a bioweapon unless you have access to a physical interface to make a thing. So we can create technology tools to make it much harder for people to print DNA and put them into cells. We have a whole list of things that the government, private sector actors are working together to build, to create barriers to people taking ideas and putting them into physical form. And that's one major way to think about it, is the digital physical interface. Unlike cyber, where you can cause harm or steal money just in digital land. In bioland, you have to make something. So that's the short answer to it. Yes, it's going to happen. We have to have a layered approach, and we have to, my personal thing on this is, as the United States is like-minded nations, we have to be the ones that demand it's defensive only.
Yeah.
And then
On the
preparedness.
issue of preparedness, and you very much specifically talked about the idea of supply chains. Look, we got to a point where the supply chains were super lean, super distributed in a way that there was one plant in Italy that made the materials that was needed for swabs that you could use for tests. And when that plant went down because everybody in that area got COVID, the whole world could not get swabs. That is just not an effective way to run a global response, right? So there's been a ton of work. I was involved in a lot of that work at the White House to build up. There are 2 or 3 elements. One is onshoring more of it. Look, there's a little bit of an element of 90% of the active pharmaceutical ingredients of antibiotics begin in China. That's not great, because that's 90% of antibiotics that we need. We need some of that in other places. So some of it is geopolitical. But a lot of it is tolerating, and that means paying for, slack in the system. having multiple places. It's not going to be as cheap as one place that builds it for the whole world, but it creates a lot more redundancy, and you just pay for that redundancy, knowing that if there is a crisis, you will be very glad. It's insurance. Insurance costs money, right? And insurance is not free. And insurance is a waste when you're not using it. But boy, are you glad you have insurance if something very bad goes on. So I see this as insurance, and there's a lot of effort towards making that happen.
All right. Wow. Somebody said mind shift earlier. I can feel my mind has shifted 3 or 4 times already. Please join me in thanking Matthew McKnight of Ginkgo Bioworks and Ashish Jha, former White House COVID response coordinator.
Thank you.